Good afternoon. My name is Kakai Shanice, and I'm going to take you through my AI project. So it's called Virtual Nursing Assistance System, and I'm going to tell you more about it as we move through this video. So the problem statement, the idea I got for this system was most times hospitals tend to be congested, like with a lot of people, and sometimes guys that have serious problems won't be like worked on because people are very many. So I came up with this idea so that guys can maybe get their symptoms from home and then come and get their prescriptions from the doctor, showing that they've understood what they have and something like that. So that was my idea. So I saw that my idea can help the community in a way that it's efficient to really help with the efficiency of healthcare. And also, like, in case you have a chronic illness, it won't get worse since you're waiting and stuff like that. Yeah. So how I'll apply my AI in this problem I'm trying to solve is I'll be using the following: machine learning, robotic process automation, artificial neural network, and natural language processing to make sure that the data got from the patients is secured into the system and enables to, and it helps the patients when they are trying to find out like their medical problems. And the data types I'll be using for this specific system, I'll be using sound, image, and text data types. For text, you'll be inputting, like, there's something I'm going to try and put into the system, like a two-choice answer. Like, are you having a headache? Yes or no? Are you having a fever? Yes or no? Like, two-choice questions. That's for the text data type. Then for images, like most time, remember, we have diseases that, like, they're like skin problems. So an image will like take notes, or maybe a rash you have on your face or your leg or something like that. So it will help out in giving you like the prescriptions that you need for solving the problem. And then sound. For sound, the data type for sound, maybe you record. I mean, some people don't want to text their problems, so they're able to record and maybe send the information to the system, and then for the system to know what's wrong, like what's wrong with the patient. Then supervised learning and non-supervised learning. Here we're seeing the differences, but before we reach there, supervised learning refers, it enables you to use labeled data, like it's organized. I can say it in such a way. While unsupervised learning, it's not organized, but actually, yeah, it's not organized. That's it. So the differences we have below. Supervised is not complex, actually very easy to compute, while unsupervised is very complex. It's really complex, and supervised needs supervision to train the models, basically the name, while unsupervised does not need any supervision in the training mode. As we move on, the two techniques under supervised learning. The first one is classification, and the second one is regression. Classification will enable the output that's put in by the patients to be categorized, like when I told you before about the two-choice questions, right? So it's like once they put in the information, it will be kept for that patient. Like, that's now the classification. Like, you say if one patient enters like patient one, put in all their data, it will be kept in one, like, can I say folder, or can I say like a file or something? That part of it will be kept in a part of the system, something like that. And then regression will enable the relationship between the data that's being inputted by the patient and the data that's being brought out by the system. It will enable, like, for example, if you write your symptoms, it will give you the solution. It's like how it's like it will be connected. It will give you a connection, something like that. Then under unsupervised learning techniques, we have clustering and association. Clustering, for this case, like if there are many patients, like 10 patients who are putting the same symptoms, they'll all be able to get the same output, like from the system, which makes it quite easy. Then association, it enables, like, if I had example, I'll use the same example. If we had 10 patients, yeah, and they had the same problem, yeah, they'll be able to get the same. Actually, they're kind of similar, but for clustering, we can say that they'll just group the patients together so that when they so that it's easier to give them one prescription. Then for association, it will look at the symptoms of each patient and see if they need to be put together in order to get their prescriptions. So they're kind of similar. Then AI technical challenges. I was able to get these three: the privacy problems, medical errors, and lack of the right devices to access the system. Now, for privacy problems, you can put your information into the system, but you're not certain that it will be kept safe. Like, how can I say, like, for example, when I put my information and like, because of like, maybe I have these so-called symptoms, and then someone else puts that same symptom, and then they give you like a reference to my information, like, by the way, this person also had, you can even get advice from them on how they solve their problems. And sometimes they make very uncomfortable with the privacy problems. Then medical errors, in a way of like, sometimes remember, systems, they also have their problems. So sometimes they can give you false prescriptions because maybe your symptoms are similar to another prescription. So yeah, there's also that. And then lack of right devices. For this system, like how to access the system, you need to have like let's say, for example, a mobile phone, touchscreen to be precise, a laptop with like some type of space, and and sometimes those people don't have those things, so they don't have the right devices to access the system. Then solutions. For privacy, the solution is ensuring a secure system will be put in place to solve the problem. Like, once I put in my information, in order for someone else to access it, I'll have to allow them to access it. Not that someone can just access just because I had the same symptoms as you. Then medical errors, they'll be solved by ensuring that the information is legit, like it's straight to the point, and to look like anybody, like a system should be able to look at it twice and see that it's not the same as the other symptoms. Like, they can be similar, but there can be a difference. Like, maybe you have all these 5 symptoms plus headache, then the other one had all the 5 symptoms without it. So you look critically. You should make sure that the system looks critically in order to make sure that such errors don't come about. Then patients, in case they don't have the devices, why to put the system in hospitals too, so that in case you can't access it from home or from where you are, and if you can go to the hospital, it's fine, but you can go there and just access the system from there too, which will make things easier for guys who don't have the right devices to use them. Then the difference between these 4: accuracy, recall, precision, and F1 score. They are metrics, evaluation metrics, actually, some part of them. So we begin with accuracy, where accuracy represents the number of correctly classified data instances over the total number of data instances. Then precision refers to actual correct prediction divided by the total prediction made by the model. Then recall refers to the calculation of the number of true positives divided by the total number of true positives and false negatives. Yeah, and then the F1 score refers to the weighted average or precision and recall, as we're seeing above. Then I said before, evaluation metrics, you're even seeing accuracy here. So accuracy, I shall begin first with the performance metrics, which have broken down into very many and countless parts, but I put a few just for you to understand a little bit about it. So they include length of stay, number of patients per day. Like, performance takes the amount of, for example, if I have 5 patients a day to be recording, something like that. So it sees how the system is performing. Here's the performance metrics. So length of stay, I can say it was like in a way of how long does the patient stay in a hospital, like admitted and stuff like that. But it was just an example, but I won't really use it inside my system. For number of patients per day, yes, I have to keep track of the records, like per day. And so many more, there are very many others, but okay. Then accuracy. For accuracy, as you saw, it was there before. It enables information got to be secure and correct for the patients, not have good guidance to solve the medical issues. Remember before we had talked about how we had medical errors of like false prescription and stuff like that. So accuracy will enable, even accuracy is another like solution. It will enable the information that's given to the students, to the patients, to be accurate and straight to the point, in order to make sure that they're getting the good guidance how to solve the medical issues. Yeah. And then for more insight on what all that I've talked about, you be able to go to these following links and learn more about what I've just talked about. So thank you for hearing me out and have a good evening.